And we were about to talk about new interfaces for musical expression in the context of academia, because until this slide, we mostly talked about what people do in the industry in the field of musical interfaces. And academia is kind of very different in many, many respects. And I just wanted to highlight these differences here. So the first thing I want to say, is that in the industry, people are basically limited to what the market wants, right? And usually in the field of music technology, because music technology is such a narrow field, the industry tends to be very conservative in terms of what you will find for interfaces and for musical instruments, because the market is so small, that they can't really take the risk to commercialize something that is going to be a little bit too exotic, if we can use that word. Then on the other hand, in academia, people are free to do whatever they want, and that's what we're going to do in this class. We're just going to do whatever we want, like we don't have any expectations in terms of the market and in terms of people using our instrument. Well, we'll try to think a little bit about it, but that's the good thing about academia. So there is a lot of space for experimentation. Now, the main drawback to this is that it's very easy to miss the point. So what do I mean by that? I mean that because we get all this flexibility, all these technologies, all these great technologies, like that we're going to use as part of this class, we can do pretty much whatever we want, and if we're not careful about what we want to do in the end as a final product, usually our musical instrument is probably just gonna fail. And so like we're gonna talk more about this later in this class, but usually in design, like people can take a top to bottom approach versus a bottom to top approach, so if you take a bottom to top approach, you start from the tools, from the technology, and then you go up to the top, like to make a product or make something. On the other hand, if you go from a top to bottom approach, you start with an idea. You don't really care about the limitations in terms of technology or in terms of if you can do it or not. And then in function of your idea, you try to use technology one way or another. And then you maybe restrict your idea a little bit in terms of what technology will allow you to do. So in the field of NIME, I would say that it's usually better to start from the top and not from the bottom, because at the bottom there are a lot of things, and as we'll see in this class. So usually, it's always good to remember that whatever you do is for musicians, and that it's going to be a musical instrument, and that it should be playable. And it's very easy to go down the rabbit hole, and just to get very excited about a technology, for example, like that you never used before, and then make something that is completely useless in the end. Like I've seen that in this class many times. Not necessarily for a final project, because we will make sure that this doesn't happen. But like for labs and assignments, like we do see like people going down the rabbit hole, like and spending like dozens of hours in a lab, and just like to figure out some kind of technology that they don't really master, but they get so excited about it that in the end they don't really have anything, or they have something that doesn't really work as a musical instrument. So to me that's a very important point, and throughout the class you should always keep that in mind. Like to me that's really a key point. So the next point is technical complexity doesn't mean quality, right? So this point and the previous one are completely connected, right? It's not because you're going to make something very complicated that it's going to be a good instrument. I mean, honestly, if you're a very good musician, you can probably play music with anything. You know, like you could probably just use, you know, like your kitchen table, you know, and with a knife and a fork or whatever, you know, and make a great performance out of it. And then as a musical instrument, maybe the kitchen table, the fork, and the knife will be better than your very complicated instrument that might just not work. You know, so usually it's better to make something very simple that works very well and that is very finely tuned. And you know, it's true for design in general and for when you make stuff. But I think for music technology, it's even more the case. You know, like you really have to be very careful about that. So you remember this guy. This is Max Matthews. We talked about him in the previous class. I just reused the picture that I had last time, you know, and so Max Matthews is kind of one of the person who started the field of nine. So it's crazy, you know, because in 1958 he synthesized the first sound on a computer, and he didn't really have any experience using well, making musical instruments or stuff like that. Like he was not a luthier or a musical instrument maker. But when he retired, he spent a lot of time trying to make musical interfaces. And in academia, he's probably one of the first person who did that. You know, like and when he was retired. And the interface that we see here is the radio baton. And if you were able to go to CCRMA, there is actually one at the entrance of the building right next to the GS1 that we talked about last time. And basically what this does is that this interface here will detect the XY position of a strike, right, on the interface. You know, like so the interface know where you're striking, but it also knows how far the stick is from the interface. You know, like so it knows like if the stick is getting closer to the interface, you know, and that's a continuous control. And then you get like velocity and the position, the XY position on the interface here as well. And this outputs MIDI, so you can connect it to a computer, you can connect it to a digital synthesizer to control it. And it basically use capacitive sensing to do this. You know, like so it's sort of the same technology as a theremin, or even the same technology as a touchscreen on an iPhone, basically. And so the radio baton is probably one, maybe even the first interface for digital musical instrument that was made in academia. And he made several of them. I think he made, you know, like 3 or 4, you know, and I think he even like tried to create a company to sell them, but I don't think it actually worked. So this is really cool. Unfortunately, I looked for a video of the radio baton, you know, like him playing it, you know, like, but I couldn't find one. So maybe you'll be better than me at finding a video of the radio baton, but I didn't find one that actually worked. Okay, so in academia, there are, I would say, two way to approach design of musical instruments. And the first way to approach design of musical instrument, which is very popular at CCRMA, is the junkyard recycling approach. And it's definitely a top to bottom approach. You know, and so a very good example of that. So by the way, the picture here is the CCRMA garage. And you probably never saw the CCRMA garage before if you never been to CCRMA, but it's behind the knoll. So and if Music 250A was happening in person, you would get access to the garage because that's where we have all the heavy duty tools for the McCausland. So there is a CNC machine, there is a laser cutter, there's all sorts of cool tools, you know, that you could have used for your project. But unfortunately, this is not going to be possible this year. And for some reasons, there is always shit in front of it. So that's why I took this. That's why I took this picture. So what is the junkyard recycling approach? So this is from Ga Wang's book, and this is a musical instrument that was made by Perry Cook, and it's a musical instrument, that is reusing a cup. You know, so the body of the musical instrument is a mug, basically, right? And what he did is that he stabbed a microcontroller inside the mug, and then there are a bunch of force sensitive resistors. So these little things here feel pressure. So if you put your finger on it, the more pressure you will apply on it, the more signal you will get, and then you can map that to sound. So so this is an instrument that Perry Cook probably made, like in 2-3 hours, maybe less, and it's very simple, but it works very well, because it fits in your hand. Your fingers find their position directly on the FSRs. You can use your left hand to rotate the potentiometer here. There is a switch to turn it on and off, and so as an interface, it works very well, but it's very simple. And it's just based on a mug with duct tape. So that's what I mean by the recycling approach. And honestly, we're going to do a lot of recycling approach in 250A this year, because we don't really have access to very professional tools to make things beside your 3D printers, right? So it's very easy to repurpose something and turn it into a musical instrument. And at first, when Perry Cook made this instrument, he probably didn't even think that he was going to use a mug. He was like, okay, I need something that is kind of a cylinder shape, and I need to put the sensors on it. Like, where do I find that? And then he was probably drinking a coffee and found the mug. And so I really encourage you to use this approach during 250A, because since we're all stuck at home, that's pretty much the only thing that we can do. But a lot of great things can come out of it. So this is another example of junkyard approach, and this one is kind of my favorite one. So this guy here is Ken Butler. You probably never heard of him before, but he's a musician based in New York City, and he makes musical instruments with stuff he finds in the street, and he makes like electric guitars and installations, like very professional. Like he's he's kind of famous in the field, and so in 2016, I went to the Goffman Musical Instrument Competition. So it's a competition which is organized every year in Georgia Tech in Atlanta. And people just submit musical instruments that they've made, and then it goes on TV, and it's like very, it's kind of a very big thing, and then the winner, gets money and blah blah blah, and so in 2016 I was there, and Ken Butler won, and it was so funny because there are people coming from very, very far away to attend this event, and to to bring musical instruments. So there were guys from Australia, there were guys from China, India, and some of them came with like gears and gears and gears of equipment, for their musical instrument. Ken Butler came with a golf club, and there was a string mounted on the golf club and a contact microphone at the bottom. And so that was his instrument. Like, it was just a golf club with a string and a piezo, like a contact microphone. And he made like an incredible performance with it, and so he won. So I think it really taught a lesson to all the people who are there, who all made like super complicated stuff. Some of them were good, some of them were not so good, but by far the best performance was his performance that he made just with this thing. if you wanna have a look at what he does, there are a lot of videos on YouTube, and I actually recommend you to do that. But like I think that's the perfect example of what you have to remember when you make instruments in Music 258. Like think simple and think musical, and then that will be a win. Okay. So here is another example of junkyard instrument. So this is John Granzo Javalili. So that was not a very successful instrument. But one day, John Granzo was a PhD student at CCRMA, like a couple of years ago now. And one day he went to Allen Steel. And by the way, if you live in the Bay Area and you want to get like metal, like steel or whatever for your project, that's the best place to go to. It's in Redwood City, and they kind of looks like a junkyard, but it's a really cool place. And when he went to Allen Steel, he found a box of espresso percolators, and that's what you have here. And he had no idea what he was going to do with them. And then he got to the Max Lab and he was like, okay, I should turn one into a musical instrument. So he 3D printed all these elements that just like go on the percolator. And he actually managed to put a little computer inside the percolator to synthesize sound. And the hole of the percolator, like where the coffee is coming out, was just big enough to fit an eighth of an inch jack in it. And so like you just like plug it to your amp, and it really sounds like shit. But it's a cool instrument. Like I hope he doesn't watch this video, but like he knows about it. It's okay. Like so I can say it. But it's a cool instrument nonetheless. It's just an example. Okay, so that was for the junkyard approach. Now there is the technological engineering and research approach, and so that approach is way more organized, and it's definitely more kind of bottom to top approach. And honestly, if you want to publish something in the framework of this class, that's probably the approach you want to take. Well, unless it's like a user study on interaction or something like that, but if you want to design your own sensor technology, which you could do, like that's definitely the approach you want to take. Okay, so let me give you a couple of examples of that. And a very famous example to me is the Slabs. And so this is David Wessel. David Wessel, and it's not Davide, it's David. Sorry, and it's David Wessel. David Wessel died a few years ago. I forgot when, but he was the director of CCRMA. CCRMA is basically the brother of CCRMA on the other side of the bay in Berkeley. And unfortunately, he died a couple of years ago. And his background was partly in making musical interfaces. And the Slabs is a very advanced interface that uses an FSR, force sensitive resistor matrix, as touch sensors to control drums. And all of that at a very high sampling rate and with very low latency. So he designed everything from scratch, like all the hardware, big part of the circuitry, and so his goal, was to achieve low latency, high sampling rates, blah blah blah. Like that's not the kind of stuff that you can do with the junkyard approach. And he also had to design his own sensor technology, which is also something that he probably can't really do with the junkyard approach. So he really like took an engineering approach to design this interface, and it was a very successful interface. And I think there is a video here of him playing it. Okay.
See? And the Z dimension or pressure dimension is associated with the amplitude.
Trying to find. So the sound is synthesized, on a computer, like, so this is just an interface, like, so the sound that you hear is it's not like coupled to the interface itself, right? And it could be anything. But the point here, is that he really wanted to make something that is fast enough so that a drummer can do a drum roll on it, and it would be able to pick each individual strike on the interface. And for that, you need high sampling rates and low latency. And this is an old project. It's from the 90s or early 2000s. And like now there are interfaces that kind of look like that you can buy in the industry, like the instrument or the Seaboard, and they are kind of the same thing, like, but in terms of latency and in terms of sampling rates, they definitely don't match what the Slabs was. Okay, here's another example. So this is Dan Truman at Princeton, and his instrument is the Bossa. And the Bossa is a cello physical model based instrument. So it has a bow sensor. So it knows like the orientation of the bow, it knows the velocity of the bow on the sensor. But even more than that, and I think that's really like the innovative part of this instrument, that you actually find somewhere at Stanford, and I'll get back to that later. But the innovative part of this instrument, is that like when sound come out of a speaker, it's directional. So depending on how the speaker is oriented, you will get different sound. On the other hand, on a cello, sound is not directional because it's coming out of the body of the instrument, and just radiates everywhere in the room. And so the Bossa is based on an array of speakers, and they are connected together, and they are synchronized to create a sound field so that it sounds more like a physical instrument. And like that's definitely a research, like technological approach, like engineering approach, and so for those of you who've seen a concert of Slork at Stanford, the Stanford Laptop Orchestra, the speakers of Slork look like this, right? Sort of. And that's because Gawong, who's the head of Slork, was at Princeton. So there is a connection between these two things. Like unfortunately, I don't think in Slork they use them as an array, because it's too complicated, and it's just like they don't create like a sound field with the different speakers, like they use them independently, but originally that's what they were used for, and so this is kind of cool to know. Okay, so sorry, like the picture is very small, and that's actually the best picture I found, but this is the Vibo from it's from the 90s. And it's also boat string instrument physical model controller. So, and for instance, it's a violin physical model controller. And so you put it, you just like hold it like a violin, and then there's a bow sensor, and it's really designed just to control a physical model-based synthesizer of a violin, and this is also a research approach. And Charles Nichols designed it when he was a PhD student at CCRMA. That was a while ago. So. Okay, so here's so that example is sort of halfway between the industry and halfway between academia, because it was developed in academia, but it eventually became a product which I think failed. So it's the case of a lot of things that we do in music technology. Like people try, and they make a startup, It doesn't always work. So so let me play you the video, and then I can explain what this is.
That's awesome.
Okay, so basically, this is modified acoustic guitar that integrates effects like an electric guitar, but the effects are coming from the body of the guitar. And so you can play it like an acoustic guitar. You can bring it to like fire camps or whatever, you know, and but you can play it, and but you can add distortion, you can add like a flanger, you can add all sorts of effects, you know, and not only that, you can also change the behavior of the guitar itself. So it means that this guitar can a little bit like the Line 6 guitars, for those of you who know what I'm talking about. But basically, you can change the timbre of the guitar so that it will sound more like a jazz guitar, or more like a nylon string guitar, or a steel string guitar, you know, and you can really do that with the little embedded computer in it. And so it's a technology that was developed at EarCam, which is the other brother of Karma in France, in Paris. And High Vibe is the startup that that was born from this technology. So yeah. Oh, that's me. So so this is the blade axe. Unfortunately, I can't show you the blade axe right now because I don't have it with me. But the blade axe is an instrument that I developed when I was at Karma a couple of years ago, and it's a physical model controller. Okay, let me show you the video. Okay, yeah, I'll just like skip to. Okay, so that part is weird, but basically it's a physical model controller. So there are virtual strings running on an iPad.
Hey, Romain. Could you turn the volume of that down a little bit? We're getting, at least on my end, I'm getting a very distorted version of that.
Oh, really?
Yeah.
Maybe it's because it's very loud here. Okay. Is it better? Better?
I can't speak for anybody else, but it sounds almost like it's way past hard clipping.
That's annoying. You know, I shared audio on my computer. Okay, let me stop the sharing and restart it, because maybe that's the problem. Okay, so share screen, and I'm not gonna share computer sound this time, and I will reshare this. Okay, and let me know if that's better. Better?
Yes.
You know, I was about to say that maybe it's just my instrument that just makes shitty sound, you know, like that's but okay. Cool. So so yeah, this is a physical model controller. So there are virtual strings running on the iPad, because there is an iPad here, and then this part of the instrument is connected to the iPad and captures the sound that you make with your fingers on little plastic tines, and so the sound of your finger goes to the iPad. It's really the sound, you know, like it's like the sound of your fingers scratching those plastic tines, and that is used to drive virtual strings. So it's really the sound of your finger that drives the virtual strings. So it's kind of a hybrid instrument, you know, like where part of the instrument is acoustical and physical, and part of the instrument is digital with the physical model. So this is definitely also like an engineering and research approach, you know, like goes like I had to make an app, you know, and like all the stuff that you see here were made from scratch, you know, like so it's not a junkyard approach. Okay. So the field of NIME is very broad, you know, and it's not limited to people making physical musical instruments, you know, and so a good example of that is the work done by Rebecca Febrink, who's a professor at Goldsmith University in London. And she worked a lot around the idea of creating musical interfaces with machine learning in them to improve the quality of the interface, basically. And so this is definitely. Sorry, I think someone has his mic turned on, and it just makes funny sounds. So, okay, cool. Sorry, I think that's gone. Good, thank you. So she does very interesting work, and if you're interested in machine learning and in musical interfaces, I recommend you to check that out. Unfortunately, we're not going to have time in this class to look at that kind of stuff because we already have like a very heavy program, and this is a little bit beyond the scope of the class. You know, like we need a 250B for that kind of stuff, basically. Okay, so new musical instruments can also be installations, and those of you who are artists here all know about like installations and sound installations, you know, like, but I just like want to show a couple of examples of that for those of you who don't really know what I'm talking about. So I think this is a good example here, and I'm pretty sure most of you have seen that one. You know, like it's kind of crazy actually, and so it's both an installation and a musical instrument. You know, like it's an installation because it's so big, you know, and people can come and interact with it, and it's seating somewhere in a room. You know, like a little bit like an organ or a carillon. And it's kind of crazy how this thing works, and it's kind of crazy that it actually works. So let me show you the video. So it's like a marble machine, right? A lot of little balls. Anyway, that gives you the idea. It's really a crazy thing, you know. Like I don't know how much time this guy spent making this instrument, but yeah, it's beautiful and it works like for sure, you know. Yeah, here's another example. So CocaNicolas is a very interesting artist, and I also recommend you to check his website because that's kind of an old project he did, and he made a lot of musical instruments and a lot of very cool, very fine, almost like Cajun, like as of John Cage instruments, and so that's one of them, and it's really cool. He makes great videos too. Anyway, so this is beautiful work, and it's very, very fine. You know, I came in a very, very well tuned. You know, and so once again, I recommend you to check his website because there are he did a lot of things, and I think he actually just released a new product today because now he actually he sells his things. So yeah. Okay, so here's a more ambitious project that you will definitely not be able to do this year. But this is a fire organ, and okay, let me play the video, and then I can comment on that. So that was at a Maker Faire, and it was very close to the CCRMA booth actually, when Maker Faire still happened in person, and so this is a diesel powered fire organ, and so it's a multi-sensory instrument, you know, like because it smells like diesel, and it's you can feel it because like whenever like the low tones start, you know, it's like a firework, you know, like you get this pulse in your chest, just like boom, you know, and so it's really cool, and it's controlled by a guitar, which is even weirder somehow. And this person here, it's like a trailer, so this person actually can carry it to do like performances in various places, and we actually tried to get her to come to a performance at Karma a couple of years ago, and the fire marshal didn't agree with that for pretty obvious reasons, and or I don't know if they were that obvious, but like I think it was fine, you know, like but anyway, this is another kind of crazy musical instrument, you know, like, that people have done, you know. Anyway, so what are we gonna do from here? So we're gonna learn how to synthesize sound on a computer, and for that we will use the Faust programming language. So I'm sure some of you know already about synthesizing sound on a computer. It's less likely that you know about the Faust programming language, but you know, like at least that will be a good reminder for those of you who already know about that kind of stuff. And by the way, it was very interesting to see who is in the class, because there is a very diverse group, which is good, you know, and usually this class works better if there is a good mix of mechanical engineers, electrical engineers, and computer scientists and karma people, you know, and I think we have that this year, you know, like so this is super exciting. So that's the first thing that we're going to do. And we're actually going to start today. We will create standalone and embedded sound synthesis and processing systems. So it means that not only we're going to learn how to synthesize sound, but we're going to learn how to synthesize sound on an embedded system. So not on a computer, but on a little chip, on a little microcontroller called the Teensy, which you will get as part of your kit. We will learn how to control sound synthesis in Faust using sensors. And you will get sensors as part of your kit as well. So you will learn the basics of electronics and work with the microcontroller. Once again, it's the teensy. So here the teensy is going to be used both for synthesizing sound and also like for acquiring the data from the various sensors that will be plugged to it. We will prototype instruments and interfaces. And finally, we will learn CAD modeling in OpenSCAD, not SolidWorks, because it's going to be too much work for this year. So I'm sorry. I'm sorry about that, but we'll use OpenSCAD to prototype more advanced instruments and use digital fabrication to make the final product. So one thing that I want to say before we move on to the next lecture is that so we're using a lot of tools in this class. Like we're using Faust, we're using the teensy, we're using OpenSCAD. If you have like an alternative to that and that you're more familiar with, I'm thinking like, for example, if like Super Collider or for sound synthesis, or if you don't want to use OpenSCAD and you already know SolidWorks or Rhino, that's fine. Do it. We're once again, we're not very sectarian. Like the goal is to make stuff, and if you're used to a specific tool, please use it. The only thing that I want to say about that, and that's probably the only limitation to this, is that there are very few programming languages that can be used to program microcontrollers for sound synthesis. You can't do it with Super Collider. You can't do it with Pro Data. You can't do it with Maximus P. And that's why we're using Faust. So if you want to use an embedded system and it's going to make sound, and by embedded system here, I mean microcontroller, you'll have to use Faust or C++. So if you prefer to use C++ over Faust, that's fine, but you'll see very quickly that it's probably better that you use Faust. Because otherwise it's really going to be a pain for you. So yes. Last point that I forgot, you will design your own instrument interfaces, installation, and showcase them online, unfortunately, at the end of the quarter. We will have a final presentation, and all your instruments will be displayed on the course website. Cool. So do you have any questions so far? Please speak up.
I just typed this in the chat, but in regards to like sensors and inputs to the teensy, do the sensors need to be analog or can they be digital with regards to latency?
They can be both. It doesn't really matter. We'll talk more about latency in this class, and usually the tipping point for latency in musical interfaces is 10 milliseconds. That's like the standard. In some cases, you need less than that, like for drum interfaces, for example. If you do like a roll on a drum, like you need less than 10 milliseconds. But like if you use a digital sensor connected to microcontroller, because all these systems are bare metal, they don't run an operating system. They're actually very fast. So whether you use like an analog or a digital sensor, it's not really gonna change anything.